So this number line diagram here, it looks like I'm adding or subtracting two numbers. I'm starting with what looks like a positive 9. I'm starting at 0 and going 9 units to the right. So that's a positive 9. And to that, it looks like I might be adding or subtracting something. I have this arrow that starts exactly at the tip of that 9, and then it goes, let's see, 1, 2, 3, 4 units to the left. So I could think about this arrow right over here as just subtracting 4. So it could just be 9 minus 4, which is, of course, equal to where we end up, which is equal to this 5 right over here. So that's one way to represent what is going on as an addition or subtraction equation. But what's another way? We could start with the 9. And is there anything that we could add to the 9 that would get us the same result? Well, we know when we add negative numbers, we also move that many units to the left. So you could also view this purple arrow right over here. Instead of viewing it as subtracting a positive 4, you could view it as adding a negative 4. Adding a negative 4. Now this is interesting, because in this case, when I subtract a positive number, it's the same thing as adding the opposite of it. Now, will that work the other way around? If I subtract a negative number, is that the same thing as adding the opposite? Let's say we had negative 5 minus negative 3. What is that going to be equal to? And let's think about this with integer chips. So we could start with 5 negative integer chips. 1, 2, 3, 4, and 5. And now I'm going to take away 3 of those negative integer chips. So I'm going to take away 1, 2, 3 of them. And so what am I left with? I am left over here with negative 2. So if we think about it on a number line, let me do that right over here. So if I have a number line, and let's say that this is 0 here, and I'm going to go negative 1, 2, 3, 4, 5. So negative 5. So this is negative 5 right over here. I can start at 0, and I can go 5 units to the left. And I know when I subtract negative 3, I'm going to end up at negative 2. So I know I'm going to end up, let me do this in a different color. I'm going to end up right over here. So subtracting negative 3 needs to be the same thing as moving 3 units to the right. If I was adding negative 3, I'd go 3 units to the left, but subtracting negative 3 must be the same thing as going 3 units to the right. Well, what also is the same thing as going 3 units to the right? Well, that's the same thing as adding 3. So this is going to be the same thing. So negative 5 minus negative 3 is actually the same thing as negative 5 plus 3. This purple arrow right over here, you could view it as subtracting negative 3, or you could view it as adding the opposite of negative 3. So it looks like when you subtract a number, it's the same thing as adding the opposite. When you subtract a number, it's the same thing as adding the opposite. Now that's really useful, because now we can even think about doing things with things that aren't even integers. We can start thinking about just rational numbers. For example, negative fractions. So if we take that principle we just came up with, and if we say, okay, well, what's 3 minus negative 2/5? Well, if we take that principle that subtracting a number is the same thing as adding its opposite. Subtracting negative 2/5 is the same thing as adding the opposite of negative 2/5. So it's adding 2/5. Well, we have seen this type of thing before, and we could even do that on a number line. Let me do that right over here. So let's say that this is 0, 1, 2, 3, 4, and 5. So we're starting here with a 3 in either case. So that's 3 units to the right, a positive 3. And so subtracting a negative 2/5, we're saying is the same thing as adding 2/5. So adding 2/5, we are just moving 2/5 to the right. So it's 1/5 and 2/5. So we're just going to do that. Subtracting a number is the same thing as adding its opposite.